Hey folks, welcome to my channel Number Pen. So there we have the problem on our screen. Find the derivative of the following function with respect to the corresponding independent variable x. So f of x equals cos x minus tan x, 2 tan x, right? So looks like it is a sum of two functions. So let's call those functions, say, u and v. And my u of x is cos x, my v of x is minus 2 tan x, right? And so what is my f of x is nothing but a u plus v. And therefore, my f dashed is u dashed plus v dashed, right? I know my u dashed because my u of x is cos x. My u dashed is minus sine x. And I put a link to this particular video where I've solved for cos x using first principles. So please take a look at it. The link is there in the description. So we know what is my u dashed. My u dashed can straight away be written as minus sine x. And then I have a v dash to be estimated, which is tan x, right? Minus 2 tan x, right? So which means we will have to solve for tan x first. And then, uh, we put it back in the v dashed of x, right? So let's solve for tan of x in this particular equation. What is my tan of x, right? My tan of x, let me call it, say, t of x, right? My t of x, which is tan x, is nothing but sine x by cos x, right? My sine x by cos x. So again, it looks like, we have a function of the type u by v, right? Therefore, we can definitely apply the quotient rule of differentiation to arrive at g dashed of x, which is our d by dx of tan x, right? So what does the quotient rule state? And the quotient rule states if my g of x is of the pattern, what do we call? I don't want to bring back u and v here, otherwise it gets a bit confusing. So let me call it a by b, right? Where a and b are two functions which are dependent on x. In this particular case, our a is sine x and our b is cos x, right? So if I'm going to treat my g of x equal to a by b, then what is my g dashed of x, right? So let's write it out. Again, I request you to take a look at the quotient rule of differentiation. It becomes very important to remember this, uh, unfortunately, by heart, right? Otherwise, it's going to take you a lot of time to solve problems of this type unless you remember these problems by heart, remember these formulas by heart, right? So g dashed of x is nothing but g times e dashed, my minus a times e dashed. Okay, so this is what we have. So when I have g of x of the pattern a by b, then my g dashed is nothing but b a dashed minus a b dashed divided by b square, right? And if I apply the same to tan of x, which is nothing but my sine x by cos x, what is my b square? My b square is cos square x, right? So I'm going to write this as cos square x. Sorry. So this becomes cos square x, And then what is my b? My b is cos x. And what is my a dashed? What is my a first? My a is sine x, right? So what is my a dashed? My a dashed is cos x. We have already seen this. Minus of, what is my a? My a is sine x. And what is my b dashed? My b dashed is d by dx of cos x, which is minus sine x, right? So I have a minus sine x here, right? So I'm going to put this in the same line. So my first part of the numerator is nothing but a cos square x, right? So I can just the cos square x. And my second part is minus sine x into minus sine x, which is a sine square x, right? So this is what I have. And I have a cos square plus sine square in the numerator, and I have a cos square in the denominator. I know what is my cos square plus sine square x. It is always 1, right? So that's the standard formula that every student is expected to know in trigonometry. So I straight away use that, and I have a 1 divided by cos square x, which is my secant square, right? So that's my d by dx of tan x, right? So that's how you arrive at it. So this is my answer for tan x, right? And remember, our v of x is not tan x, it is minus 2 tan x, right? So So let's go back to the main expression and rewrite our f dashed of x, right? Our f dashed of x is nothing but u dashed, which we know is d by dx of cos x, which is minus sine x. And then I have my v dashed, which is minus 2 tan x, right? Sorry, which is d by dx of minus 2 tan x, right? So my minus 2 can be pulled out, right? Because it's a constant. And what is my d by dx of tan x, which is what we saw using the quotient rule of differentiation? It is nothing but my secant square x, right? So let's write that out, secant square x. So minus sine x minus 2 secant square x is my final answer for this particular question, right? So, as a part of this problem, you have learned how to solve d by dx of tan x, right? Using the quotient rule of differentiation. And remember this formula, we're going to use this directly in some of our upcoming videos. D by dx of tan x is secant square x, d by dx of sine x is cos x, d by dx of cos x is minus sine x, right? So these are the three formulas we have learned so far, and please remember them when because we're going to use them directly to solve some of our upcoming problems, right? I hope you found this content useful. Please do subscribe to my channel and support. Thank you.